Hey Sameep, hey Somashri, hey Nishtha, how are you doing? Hey Shubham, turn on the mic. Perfect. Good. So let me pull out. Some of you have done a good job and submitted the work. I'm very happy. And yeah, all right. Today I got really, really good questions to solve together. Okay. Something that'll, be useful to all, as well as something that is related to the loops and something that is as contemporary as the chat GPT's way of producing output. Okay, all the things combined, though the things are pretty simple, and but things are still complex at the same time. So I've prepared today, at least, but I have to type the questions. I'm yet to I've thought about the entire process. Okay. So you'll have a good time. I can guarantee that part. And yeah, so the flow for today's discussion is going to be, first, we will revisit the questions that we have done in past. Okay. And and we will revisit afterwards. We will uh, we will start with serendipity. The topic of today's discussion is going to be how would you code serendipity? Okay. And yeah, so that will be the core idea. And it'll go slowly, and you will say that these complex ideas are so simple. Okay. And okay, perfect, perfect. I'm waiting for everybody to keep their cameras on. All right. Perfect. Perfect. The yeah, perfect. Everyone keep your cameras on. They make the class lively. And I know that online classes are hard and they are kind of painful. Specifically, like online meetings are hard. Online meeting people is hard. Hey Neil, how are you doing?
Hey Sandeep, doing good, doing good. How about yourself?
Good, good. And
Finally able to join the class live for
yeah,
a change.
yeah, I've been missing you. Like, where are you?
Yes, yeah, I had faced a very small, not actually, I got an ACL tear. So I was in surgery and recovery for that. So that took a while. But
I
thankfully,
do.
the recording classes kept me busy.
Oh, you
So it's
went
been
through.
good that way.
Okay, 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 okay. Good, good. All right, all right. So I know some of you have submitted your exercises, and can you, yeah, you want to go ahead and share? Thank you, Sweta, for keeping the camera on. Yeah. Hello, sir. Hi. All right. Thank you, Veena. Thank you, Gaurav. All right. Yeah, so some of you have submitted. You can raise the hand and you can share your code, and we'll go through those exercises. Okay. So far in our classes, we have gone over the loops. Okay. And we will be covering the exercises related to the loops. Okay. And yeah, some of you have submitted. Can you raise your hand? I'll have to otherwise go to my submission. I saw the submissions. Okay. I saw the submissions. Let me pull out the submissions. People have my team has assigned those emails to me. So I'll just have to open them. Okay. Veena has submitted. Okay. Yeah. Veena, could you share your screen and walk us through your code?
I have not opened Jupyter. Let me open. Yeah, you mean the homework of last day, right?
Yeah.
I have not got one question. I mean, half of that question.
Okay.
Mm.
Okay. Go ahead. I will, but in the meantime, I'll just open my notebook so that.
Can I open, Sandeep?
Yeah. Go ahead.
I'll share. This was the Tower of Hanai that we have already discussed, and this is the one that is match thing. No, the star I couldn't match. Only question mark I could match.
Okay. Good.
And
Okay.
the next one was
Yeah. That one was a bigger challenge, the regular expression one. I want to take some time, probably towards the end. I will address that. Okay. This one is hard for everyone right now. So take your time. I'm really happy that you are in right direction. Okay. You are in very right direction. You just have to continue that thought process. Your thought process is absolutely right. That thought process is absolutely right. So carry on with the thought process and, think of it this way that, right? The way I would think of it is this, that, I mean, the same thought process that you're having. Let's say you want to match A star B, right? So what you do, and let's say the string is ACB, okay? So what you do is, if the string is exact character, you just match it and proceed. Okay, so consume this and call this recursively. Okay, got it? So
yeah.
If the letters are identical, first letter is identical, what you do is you say, okay, remove the first letter. Now call the same function with asterisk B and match it with CB. Now what you do is you say, okay, you start looping here, start saying, okay, consume. Now you can say match B with CB or match B with B, like that. Okay. So if this asterisk means either you consume one letter or don't consume any letter or consume more letter and so on. So it becomes a recursive call. Okay. So again, those who are new, okay. So problem statement was, this is a hard question. So the reason I am discussing it is because so that you all can you know, start thinking in that direction. It's a recursive function. Okay, it's a recursive function. Okay, let's say if AB, will it match with AB? Answer is yes. What you do? Check the first letter, and eat the first letter from both sides if they are equal. If the first letter is not star and is basically not question mark, and it's not same, then return false. Okay, but for returning true, you'll have to work a little bit more, right? So basically what you do is you check, right? This, let's say this is your pattern and this is your text. Okay, you take the first letter, check, is this right? Are both of these exactly same? Okay, if let's say it's not question mark, it's not asterisk, it's A. It should be A. Otherwise, you just return false. If it is A, now you check for the rest of the string. You say, okay, is B is matching with B. Okay. Now, let's say here it's asterisk A, B, B. Okay. That's your string. So what you'll do is you will try number one, try matching B with A, B, B. You will try matching B with BB. You'll try matching B with B. Okay. And if any of these is correct, that means it's a regular expression. It's a, it's a match. Okay. So you basically will apply a for loop with a recursion. Okay. You will start eating one letter at a time, comparing the remaining this B with this, B with this, B with this, and so on. Okay. We will, again, I'm giving you some time to think over in your own style and give it a shot. Okay.
Yeah, I'll try that.
Okay. See, if you go up, you see, you have said if pattern equals to text, you are returning true, correct? Which means if the letters are identical. Okay. Instead, I would say if pattern 0 is equal to asterisk or something, then do this. Otherwise, if it's not asterisk or question mark, it should be identical. If it's not identical, return false. Otherwise, eat that first letter and match, recall this is match recursively. Okay?
Yeah, each time in each match, I'm giving
Yeah. That's what I saw. That's a correct way.
That is the okay.
That's a correct way. Okay. So here you just have to put like first, block that, okay. You got the idea. You got the idea. Okay. Yeah, you got the idea. You are in the right direction. Okay, perfect. Very happy. Okay.
These are the two vectors.
And if you can solve that question that much, right? Give it one full day of your time. Trust me, that regular expression. Yeah. And if you give that one day of your time, you will be able to crack most of the Google interviews, Google level interviews, hardest interviews in the coding. Trust me on this. Okay. So yeah, give it your time. It requires one day of your time. Okay. Yeah. All right. Now you're saying diff of two vectors, array 1, array 2, index equals to 0, result is this, while index is less than length of array. Okay. What you're doing is you are appending array 1 index minus array 2 index to the result, and you are increasing the index plus 1. Perfect. Very good. Very good. And then you are saying diff of vectors 1, 2, 3, 3, 4, 5. Perfect. Is this code clear to everybody, or you want me to, can you zoom it a little bit, Veena?
Yeah.
Okay. All right. All right. So diff of two vectors Okay. Has anybody else done it? If you guys want to show your code right now, it'll be good. Has anybody done it in another way? Okay. All right. So diff of two vectors, array one, array two. Is this code clear? Basically, we
I
want
used enumerate function.
That's good. Okay,
So
that's
I
good.
was looking what are the different kind of functions available. So
That's good. That's good. I want to see your code. Can you post the code? Or Veena, can you also post your code? Okay. In a moment, I think I'll let you share, Madhumita. I think that'll be good. Or what can be a good way that I can let quick, or you, Madhumita, for a quick moment, let's just take a look at your code as well, when we are talking about diff of factors. Okay. Yeah, you share your screen, please. This is good.
posted it.
Okay. All right. Okay. Veena, can you copy paste this in your notebook and you can share your screen? I want to keep that.
Yeah, sure.
This is good. Super happy.
I think I'm sharing correct screen,
Yeah.
right?
Yeah. So yeah, just insert one cell, press escape and press A. Okay. Press escape and press A. Press A. Yeah. All right. Yes. So, okay. The whole code did not come. Okay. There was a for loop also. This part.
Okay.
I value enumerate, print AI, print B, and so on. Okay. All right. Okay. So let's compare the two code and the two pieces of code. I think this is very, very good. Let's take a look. So is everybody clear about Veena's code? This is a very simple code. Initially, she has initialized here index equals 0. Okay. This is index equals 0. Okay. And then this is the place for keeping all the results. Result equals to empty array. This is empty array, empty list. And this is the initial number. Now what here you see the code, it says while, meaning these two lines of code will keep on repeating until the condition is true. Until this condition is true, this condition, it says index is less than length of array 1. Okay. Now, here the only trouble that could happen is if length of array 1 is lesser than length of array 2, or length of array 1 is bigger than length of array 2, what will happen? Length of array, it will overflow the length of array 2, right? And it will say, oh, overflow. Okay. Anyway, we are ignoring that kind of troubles. We are assuming that array 1 and array 2 are both of same length. Okay. So we are checking, is 0 less than, let's say array length is 3. Okay. So is 0 less than 3? Yes. So it goes here. And what it does is it accesses array of 0, array 1 of 0, 0th element of array 1, 0th element of array 2, and subtracts them and appends it into the result. So let's say, take the case of 1, 2, 3, it will basically say 1 minus 2, which is which will be minus 1, and result will become minus 1 after this. Then again, index will increase to 1. The next time, array 1 and array 2 will be 2 minus 3. So this will be here, index is now how much? Index is 1. Index equals how much? 1 now. And array 1 and array 2 will be 2 minus 3. So this will be 2 minus 3, which means minus 1. and it will be appended to the result. Okay. Now index will increase by 1, so index will become 2, and it will be 3 minus 4, 3 minus 4, and that will be appended to the result. Okay, so that's about it. And we basically have difference of two vectors. Okay. So this is good. Now let's take a look at the second piece of code. Second piece of code, again, there can be, I mean, you yourself will write different code every time you solve a problem. Okay. It is impossible to remember the code or memorize the code. Those who memorize the code, they fail every interview possible. Okay. So don't need to memorize anything. Instead, like my favorite questions are those in which even those who have already done those questions, they have to rethink everything. Okay. So I mean, every piece of code would be mostly different from the other person. Okay. Now here, what she has done is instead of taking the vector, taking the input, she has taken the vector, but this will be string, Madhumita. A will be string, B will be string. Okay. Can you, yeah, can you,
Also, I faced one issue kind of. I was thinking if I enter vector 1, then it will take like all integers. So how, like Veena has given directly vector, okay, like that quote and bracket and all. So I was trying in input like that bracket, and it was not. It was identifying each character as one.
yes, yes,
So
yes, yes, yes.
I thought
That's
why
why,
it is happening.
yeah. That's why it's very impossible. So you can move A comma B to the parameters for now. Okay, we are
Okay.
assuming that we have already taken the vectors.
Uh,
Vinny, can you move A and B to the parameters, delete both the lines and say A comma B here. A
okay.
comma
Okay.
B. Yeah.
So
And
if we want to prompt user, then what we should do?
what you have to do is you have to ask the user to enter these numbers. Then the entire thing will come as a string. Okay. Then
Mm-hmm.
you basically either say split it based on the space. You can ask the
Oh,
user that enter the number separated by space. Okay.
acha, acha, acha.
And then you split
Oh,
it, and then each number you have to convert from text to the number. Okay.
okay, okay. So I have to do that extra thing.
Yes,
I thought
yes.
Python is so smart, so Python will
No,
do
no, no.
everything, whatever I am thinking.
No, Python gives you tools. Python gives you tools to do it. If it does that, right, some programming languages did all of that. Okay. It becomes so confusing to people that it's impossible to figure out whether it's considering it as a number, a string, or what's going on. So it becomes very messy.
So
Okay.
Sandeep, there is no way the way we define int or float or string and then save those in parameters. So in case of array, there is no such
So
mechanism.
what you can do is you can ask people to enter JSON object. There is some format called JSON. And once people enter that JSON, you can just load JSON from text and convert it into an array in a fraction of a second. Okay. So there is a better format of storing the data that's called JavaScript object notation. So you can ask the user, put this square bracket and enter the data in the form of JSON, and you can translate it back quickly into this text. Okay, I'll show you that part today.
Yeah.
It's a
Okay.
good that you reminded me. Okay.
Sure.
So I think that'll answer Madhumita's question as well. And yeah, so, and that will also, we will, even though we will discuss that in future, but it's better that you ask this question now so that, it can become quite handy. I'll have that today. It's called JSON object. I'm making my notes. Okay. Let me make my notes. Okay. So I have to talk about JSON and serendipity. Then I will talk about the past exercises. Okay. All right. Let me go back. Yes. Yeah. Perfect, perfect. Now comes the second question. Second question is absolute distance. Okay. Yeah, I missed Sweta's that did not complete. Go back. Yeah. Here, so we are saying A comma B, right? And we are saying enumerate. What enumerate does? It gives you two values. One is the index and a value at that index. Instead of we accessing it again, okay, so we can just use that value, okay, even though she's not using that value anywhere, but still it gives you two things in a single shot. Okay, so here I comma value in enumerate means I will be the index and value will be the value. For example, if we are calling it with 1, 2, 3, enumerate 1, comma 2, comma 3, I will be 0, value will be 1. Then in the second loop, the I will be 2 and value will be, sorry, I will be 1 and value will be 2 and so on. Okay, so essentially, if let's say A is equal to let's say 2, 3, 4. So first time I comma value will be these will be 0, comma 2. Then next time I comma value will be 1, comma 3. So 2 and I next time I comma value will be 2, comma 4. Okay. Uh, or if this was 20, 30, 40, this will be 20, 30, 40 because this is 0th index, this is 1, like that. So enumerate essentially does it. Okay. So basically this value AI is essentially in the value. So you can actually write val here instead of AI. Okay. So and that's it. And yeah, and the thing is, don't get confused that the same variable is being used here. You can generally use D here instead of val, and that will be better. Okay. So essentially, it's the same thing. Instead of a while loop, C is using a for loop. For loop is a definite loop. For loop is guaranteed to stop, and for loop doesn't have this infinite recursion. Okay, the only problem with the for loop is that it is only over the list of values. Okay, you cannot just jump back and forth, you can only go forward. In case of while, you can basically do whatever you want with index -1 +1 index 2 and so on. Okay, all right, all right. So is everybody okay till here? Yeah. Thank you, Rahul, for keeping the camera on. And I mean, yeah. Let's go ahead. Next question. Any questions so far? Please feel free to raise your hand.
I mean, I've never done this before. I just joined last week. I'm trying to catch up with the recordings. So I
Okay.
won't say I understand everything, but it's helping.
Okay. Okay. I mean, do you find anything confusing?
No.
Okay. Okay. Everyone, please feel free to stop because if you are having doubt, there'll be more than 50% people in the class would be having doubts. Okay. Yeah.
Actually, I have one doubt.
Yes.
I actually didn't understand that enumerate part.
Okay. I'll go over it. Okay. Let me copy paste the code and yeah. All right. This yes, previous was 18th, correct? Yes. Okay. Yes. So we are talking about this one, right? All right. And today, yes. All right. Given two vectors or arrays, arrays a list of numbers, return the difference of the two vectors. Okay, difference 1, 2, 3. If this is one array, this is another, subtract each value from other and give it the outcome. Okay, let me just show you. Let's call it right? Diff underscore vectors. Okay. And let's say this is my vector 1, this is my vector 2. Okay. And what I'm going to do is there are first method is I use a while loop. Okay. The one that which maybe I had used, or okay. And Veena, could you just copy paste? Otherwise, I'll just start. Okay. So index is 0. I'm saying while length of index, okay. If here I can put one more check. If length of A is not equal to length of B, okay, just return none. I'm saying don't return anything and just print error. Unequal lengths. Okay. And I'm just returning none. None means I don't know the outcome. It's a way to return that I'm not able to, sort of an error. Okay. Now, though there is other methods. Okay. In production environment, you would use something called throws exception. Okay. We'll talk about exceptions soon. So what we did was we did an error checking. We said, okay, if the length of the two things is not equal, we cannot find the difference between them. Okay. Then we said index is 0, meaning we are going to keep a variable beginning of this. And we are saying while length of sorry. Okay. While
I have
index
pasted the
is
code.
length of A, okay, we are going to say if right, we are going to say the delta is A of index minus B of index. And then I'm going to keep one more placeholder for result. Okay. Here I'm declaring an empty list called result, where I'll be putting the outcome. So I'm saying result dot append, and I'm putting this value and returning the result. Okay. Now we can say diff underscore vectors. Okay. And we are saying 1, 2, 3, and 4, 5, 6. Okay. See, I made a mistake here. Can anybody notice it? Can anybody notice the mistake? Quickly.
The index is not incremented.
Yes. Yes. So it has gone into an infinite loop. Okay. I ran it. It just kept on going. You see the asterisk? It means it has gone into the infinite loop. Okay. And that's the reason why people do not prefer while loop, because there is a chance of making mistake that, okay, I forgot to increase the index and index remained 0, and it kept on checking 0 less than length of A, 0 less than length of A, and it kept on computing, and it kept on going. If you don't believe me, I can just show you. Okay. Print index. Okay. And let's say, okay, and print index, and I'm also printing result. Okay. Now it will overflow my screen. Yes. So it is going crazy. All right. Interrupt. All right. So you see, in case you get into this situation, just go to kernel and interrupt. So what's happening here is that we are iterating over it indefinitely. Index remains 0. It keeps on adding -3, -3, -3 to the outcome and just keep on going there. Okay. Yes. So you might say that Python is not smart, but it is not supposed to be this smart to figure out that we have made the mistake. Okay. Yes. So what we do in this case, we increase index by 1 every time we finish. So first we access the 0th element, subtract the corresponding 0th element from second, and then we go to the first element, do that. And the moment we reach the index equal to 4, we stop. So you can see now, okay. So first index was 0, then 1, then 2, and that's it. Okay. Okay. That's about it. So there we go. So this is a while way of
Just
doing it.
one another thing. So we don't define normal variables in Python, but here we are using list result. So we have to define it, right? We can directly append result dot.
Yes, yes. So we are not declaring anything. We are just creating an empty list so that we can put into it.
Yes, yes. No, I am saying if we don't create it empty list, then
It will
this
give an
not
error.
what. Yeah,
It will
it
give
will
an
give
error.
that. Yes, yes.
Yeah. Because see, result.append, result is none. When you have the variable doesn't exist, result is none. And we are calling the value append method on none, and it'll throw an error. Okay. So whenever you want to read something, you have to initialize it with some value. Okay. But if you're just setting for the first time, you don't need to declare it. Okay. Like for example, if you want to say print X, okay, print X, you have, it says X is not defined. Okay. But if you, right? But you can say X equal to 10, X equal to 12, because here you are assigning value to it. So set method is allowed on undeclared things, but get method is not allowed. Okay. Similarly, append method will not work because this does not exist. Okay. I hope it makes sense. Now, this is my while loop. I wrote that while loop. Now let's just, this was Vina's way of doing it. Now let me just go ahead and write the second strategy. Okay. Second strategy was like what, who had done that? Yeah. Madhumita had done that. Okay. So now, like, there is a very nice thing called enumerate. What does enumerate do? Enumerate iterates over things and gives you two things at a time. For example, let's say this is my list, A equals to 1, 2, 3, 4. Okay. What you can do is you can say for I, comma, value in A, in enumerate, or let me just go over the loop first. Okay, there is something called for loop. Okay, and what for loop does is when you have a list of things, you can go over those list of things using for. So I'm saying for value in list print value, meaning for each of the value in this list, I am going over this. Here, A must be something that is like a list. Okay. So this loop takes each element, plucks each element from A, puts it into B, and gives you this. And that's it. It doesn't change the list A, it only just goes over it. Okay. Like for example, if this was Sandeep, this is first text, and this is let's say Sameep, and this is Neil, and this is Rahul, right? So what it does is it basically, this is a list of text strings, right? This is a list of strings and it is going over this list of strings. Okay. So this is my for loop. Okay. If I have to do a for loop, right, it will be difficult to do the for loop here to do the vector because I need the corresponding index in the other vector. Now, what I can do instead is I can use something called enumerate. What does enumerate do? Okay, let me show you the enumerate. What does enumerate do is it gives you the index also. Okay, so that because for loop does not give you the index right away. Okay, so now enumerate gives you two values. One is I and other is the value, the index and the value. Okay, let's print index as well and then see. So it says I is 0 and value is Sandeep. I is 1, value is Sameep. I is 2, value is Neil. I is this. So, and also what you can do is just to be clear what's happening, just print the dashes. So it prints 0, Sandeep, dashes, 1, Sameep dashes, and like that. Okay. Now let's take a look at for I value of A. Yes, Rahul?
Yeah, Sandeep, this is one thing I just want to understand.
Yes.
Like in the for loop, you are calling out a single array here, but you are referencing two parameters like I and B. So
Yes.
how does that gonna work? Like this is I understand in this case as an index,
Yeah. Yeah.
but I've seen people are using these
Yeah. So what's
two
this
two
enumerate
temp
doing?
variables in the for loop actually.
Yeah. Yeah. What enumerate is doing, I'll tell you. So what an enumerate is doing is that it is kind of converting this into a pair. Okay. So you can think of it this way. Okay. What enumerate is doing is preparing this kind of a pair. Okay. All right.
Okay.
And it's a list of tuples. Okay.
Okay.
List of tuples. So now we do, if let's say A was this, we could essentially do the same thing.
Okay.
Got it. So here, it's a list of, okay. So it created internally, it converted each element into like a pair of things, index and value, index and value. And then for loop went over that, assigning those two things into this, because you can assign two things in Python like this, right? IV equals this, okay? So it'll basically say I is this, V is this, right? So it basically assigned those two values into each one. Got it? Is everybody on the same page?
Okay. Yeah, I got it now.
Okay. So enumerate essentially converts this list of strings or list of things into list of pairs. And each pair is containing index and the actual value. Okay. All right. All right. Yeah. So enumerate essentially converts each value into sort of this. Okay. So what I'm going to do is I'm saying here I, or I'll just call it index and value of A, enumerate A, and then now I'll say difference is equal to value of A minus B I IDX. Okay. And I will say result equals this and result append D. And in the end, I am returning the result. Okay.
Yeah.
So here, let me just test it out. Okay, let me just test it out. Does it work? Yes, it did work. Is this code clear to everyone? Please feel free to call out right away. Okay.
Can you explain this line number 4? How does it using that calculation?
Line
B.
number 4. Yeah.
Yeah, B of,
See,
yeah.
Yeah, perfect. So see, VA is okay. So VA contains the value of A index, correct? Let's say the VA will be 1 first time, then VA will be 2, then VA will be 3 as the loop is going, correct? So index will be, let's just print it out. Let's just print it out. What is index? Okay, I'm saying index colon, and this is the coolest way to print things. And yeah, so let me just show, oh, I have to put F. Okay. Yes. Okay. Now, so for the first time, our index was 0. Now value was 1. Second time index was 1. Basically, we are going over only one of the list. Correct? We are only going over one of the list. And then what we are doing? We are taking the delta of VA, and B index. Okay? Because index is, we want to basically take this value, go to the corresponding index, subtract that value, and append that difference into the result. Okay? Now here, is it clear? What does VA contain and what does index contain?
Only what this enumerate means? Is it converting the value to numeric something 0, 1, 2 like that? Like enums 2?
Yeah. It converts basically, let's say enumerate, what it does is, if your list was this, Sandeep, Sameep, Neil, and Rahul, what it does is, it converts each of the members into sort of like a index, comma, actual value. Index, comma, actual value. So when we are iterating, we get two things instead of one. Usual for loop will only give you one single value, and that will be of no use to you. Okay? And you would want the index also, correct? If you use a for loop, let's say I'm using a for loop to do it. Okay? Let's say I would say here, value of this in A. Okay? So what I'll to do? First of all, I'll just keep index equal to 0, and we'll keep on increasing index by 1. Okay? So now this again, if you take a look at this one, okay, so you can see diff vectors. Okay, you'll see so many variants today. Okay, for a single piece of code. So we are saying result is empty array, index is 0. Then we are iterating over array A. Each value goes into for loop and VA. Initially, the VA is going to be 1, then 2, then 3. And then we are subtracting the two values and putting into the result. And that's about it.
What is the return type of enumerate? Is it like, because you're using in, so is it a list?
Return enumerate is a list. Enumerate.
So the return type
There's something called iterable. Okay. There's something called a
iterable. Okay.
Yeah. Okay. So basically anything that is iterable can be iterated using for loop.
Okay, so that answers the in part, but what is the return type of enumerate? Is it a list, you said?
It's a list, yes. You can just take a look. I'll show you. Okay. Let's say we say enumerate one, or let's say Sandeep, and let's say Veena, and let's say Subodh. Okay. So this is the enumerate, right? It returns an enumerating object. What you can do is you can just convert it into a list quickly, right? And check. Okay. So it converted Sandeep, Veena, Subodh. This was a list. It converted into a list of tuples. Got it?
And can we change that index like in C++, Sandeep? User can change that index, like he can start the enumerate from 1 itself instead of 0. This is possible via using structures of classes.
Yeah, you can. What you can do is you can say, okay, I'm not sure you can do that, but let me just give it a try. Okay. Enumerate is not scriptable. Okay, you can't do that. Okay. But in case of a list, after you have converted to list, you can do that.
Okay.
Okay.
So basically enumerate gives you the enumerate object of enumerate class, which you can convert to list or anything you want, right?
Yes.
And then operate.
Yes. Okay. Enumerate is like it's not a list. It's like a, what do you say, cursor. In databases, you call them cursor, right?
Okay.
Or iterator, those who are coming from Java. Okay. Or a pointer. Okay. Is it making sense to everyone? The enumerate. So enumerate is not really a part of for loop. Enumerate is a separate function which converts a list into a list of tuples, and each value becomes that. Perfect. Everybody okay with me so far? So first version of code was while loop. First version of code was while loop. This one is okay with everybody. Second version of code was a for loop in which we were keeping our own variable in index, and we are keeping that increased. Okay, so we are increasing that every time, and we're doing that. Third version of the code contains the enumerate function. Okay, which essentially gives you the index. Instead of you keeping a track of the index, the enumerate is keeping the track of the index. Yeah. Making sense to everyone? Okay.
Yes.
All right. Those, as we will be going into the data science and AI, this thing is naturally there in something called a NumPy. Okay. So we can say import NumPy as NP. Okay. And we can create np.array like this, 1, 2, 3. And we can say np.array of say 14, 51, 62, and there you go. So you can just subtract the list of numbers like this using NumPy array. Okay. So essentially, the NumPy is designed for vector operations. And when you subtract the two vectors, you get a new vector, which is a individual value subtracted. Okay. So it's a common operation. We'll be using this very often when we are dealing with machine learning, because we'll be dealing with numbers. Let's say person 1 is having these characteristics, person 2 is having these characteristics. If we subtract the two, what do we get? Okay. Similarly, in many more things, like for example, visually, the way, let's say there is there is something called vector additions. Okay, what does vector additions do is, let's say there is a there is a person walking in this direction and the wind is blowing in this direction. The new numbers will be in this direction. Okay, if this vector is 1, 2 and the wind is 2, 3, this vector is going to be 2 plus 1, 3, 3 plus 2, 5. Okay, so these operations of subtraction and additions are so common in machine learning that there is a complete library for doing the same thing. Okay, so yes, though we are reinventing not because we need too many arrays to be subtracted. We are reinventing so that because we need more inventors who can invent new things. Okay, so that's a very important part. Many people will question that why are we doing this when there is already a function in NumPy? Why are you making us code? It's not it's like a workout that, okay, it's like a workout that even though you go to the gym and you pull all the weights, it's not actually a work per se. It's not adding any value, but it is adding value to you. So that's why we're doing these exercises. Okay, so think of it that way. Now, coming back to it, let's take a look at a very interesting way of doing it. Let's take a look at Sweta's attempt. It's a very interesting way of doing it. Let's take a look. Yeah. So vector difference is this. Now, this is most cryptic code that you will see. And I have a huge temptation to park it aside, but I'll still give it a try. Okay. All right. So let's take a look. All right. Now. Huh. There are many concepts in this, okay? And first concept in this is something called, right? This is a very important piece of code, okay? So first concept is called zip. When you zip, there is a function. This is not a core library. It's not like you know, without zip you won't be able to survive, but without for loops you won't be able to survive. Okay, so it's okay to know zip, and it's quite handy. Okay, now let's take a look at what does zip do. Zip creates a zip object. So let's just convert this again iterable. So I'll have to convert it into lists to see what happened. So what it did was it took 1, combined it with 3. It took 2, combined it with 4. It took 3, combined it with 5. You can see 1, 3, 2, 4, 3, 5. Cool.
Yeah.
And now what you can do is you can say for A comma B in list, and you can take a look at this. Okay, so it has done the subtraction for us. Okay, let me make it a little more interesting. Okay, yeah, right. Now what we can do is we can just put it in the result equal to empty, and I can just say result dot append A minus B, and then finally I'm printing the result. Okay, instead of putting it in the function, I have just put it into this. Okay, let me just make it a function. Okay, I'm making her code you know, more like stepwise. Okay,
Yeah.
and let's take a look. Perfect. Is everybody okay with so far?
Yeah. Sandeep, just one thing to ask. Is zip a core function or a method like print in Python?
It kind of, yes. It's like print. It's a method that is provided by them.
Okay, so I was checking whether it's part of any library or not, which is pretty important.
No, it is not part of library. Just like print, it's available by default.
Okay.
Okay. Is everybody okay with this?
Sorry, just what exactly zip did? Zip only created sort of like enumerated created set of iterator and the value, right? In zip you created a set of value from both.
Yes. It basically created list of tuples, list of pairs. You can see bracket, round bracket inside. Okay. So it took the first element from this first element, put them together. Then second element, just like in zip, when you take the zip's hook, it take both the things and put them together. Like if you remember, like from both the sides, it takes them and puts them together.
Yes.
That's what it did.
And
Corresponding element here.
and then when you and then when you did for AB, it actually, so in for loop, any number of variables you give, it will take the number of
yeah. So it
items
is
from
like
that
this.
tuple.
It is
Okay.
like it is like this. Okay. It is like this. So it is, we are iterating over the tuples. This is the tuple. Okay. And then we are assigning it to AV. Got it?
Okay. Got it.
All right.
So Sandeep, let's take an example. I mean, I'm just thinking, let's say you have two arrays, like one containing 4 elements and another one containing 6 elements. Then how the zip function behaves in that case? Will it
It'll throw
kind of
error.
combined or?
No, I think it'll throw error. If 4 and 3, okay. Yeah, it kind of ignored the last element. It ignored this one. Was that your question?
Sandeep, does this mean it doesn't taking the length consideration of that?
It is taking. It is taking. What it did was it took the smaller length array and used that for zipping. Okay, like for example, I threw an error right in the beginning. What it is doing, instead of throwing error, where is my code where I wrote that piece of code? What? That's my notebook, right? Oh, I wrote that code. Yeah, here. Okay. So if let's say, right, this one, okay, we can also say if length of A is bigger than length of B, okay, swap the arrays, meaning A will always be smaller. That's what it did. So when we use this kind of thing and we are saying 1, 2, 3, 4, what it does is it'll basically first switch these two values, like this array will become the A and this will become B. I said, if length of A is bigger than length of B, swap the two. Okay.
But Sandeep, in this case, the value what we're receiving in the positive one, no? Ideally should be like -13,
Yeah.
-49.
Yeah. So that's a kind of you can say a mistake here. Okay. Now you are right. So I'm just saying that it has kind of just taken the smaller length of the two and iterated over the smaller length. Okay. So where is, yeah, this logic is wrong. I will revert my logic because the subtraction is not reversible. You can't say A minus B is same as B minus A. Okay. All right. So that is wrong. In this case, it is just throwing error. I would prefer an error. Okay. I would prefer an error. I would not prefer it to do something intelligent. Okay. All right. Is everybody okay? Let me go back to the code where I was. Yes, we were here. All right. This is okay to everybody? All right. I will again, these two steps I can combine this assignment to AV into tuple. I can just say here A comma B. That's it. All right. So it is working fine. Now, further, what you can do is, let's say, whenever you want to put something into an outcome, let's say you have a result, A equals 1, 2, 3, and you want to double each value of array A, you can say for v in A result dot append 2 times value. Okay. So let's take a look at this one. Okay. So I just doubled all the values of this. Now, for this kind of thing where you always have to produce a new array, right, in a for loop, if you have to produce a new array in a for loop, for this kind of situation, the Python has come up with a better, syntax. Okay. So these two pieces of code are identical. Okay, so there is another way, another syntax for loop. Okay, there is another syntax for loop in which, okay, so here let's take a look again.
Sandeep, one thing. In the 54 segment, why it is A comma V that is still working? It should be A comma B, right? How it is working?
No. So you are so right. Yes.
But it was working. Okay.
I think it has picked up the value from the previous or something.
Okay.
Yeah. Okay. Good catch. Good catch. I don't know why it was working. Yeah.
Okay. And the 56th one and 58th one. So it should be 2 star V for
2 star V.
That is what you meant, right? Okay.
Yes. Thank you. Good. You guys are paying attention. Okay. Good. Very good. These two code, like this one and this one, both are equivalent. Okay. Here we are creating an empty array result, going over V, producing result by appending these values to this, and so on. People found that this was very common situation in Python. So they came up with this syntax to do the same thing. Okay. So it's like select star, select something over a list, right? You remember the select syntax from SQL? This is like that. So we basically, if we want to, let's say, convert every number into negative, we can do that. Okay. Or and so on. So there is a very common need of iterating over things and operating on that. Let's say you want to do square of all the values. Okay.
That square bracket is required. Is it mandatory?
Yes. A square bracket is representing that this is my result. Okay. This is the result. Okay. And we can say print result. Okay. Everybody okay with this? So we talked about while loop, we talked about for loop, we talked about for loop with enumerate, we talked about the NumPy way of doing it, we talked about this is called list comprehension. List comprehension. I think that's what it is called. Okay. Now let's take a look at this particular code. So what she has done is, first, she has put in a zip, okay? And this is wrong, so I have to change it to L1, L2, L1, L2, yeah, okay. So no, there's something wrong, right? It's printing the result here. Yeah, this is wrong. It was not doing anything. Yeah, no. So you were right. There was something seriously wrong with that code. Right. Now, coming back to it. So here, there are two things it is doing. Number one, this for loop is basically, first of all, it is zipping. Before the for loop starts, L1 and L2 get zipped together such that the values at each index are paired together, right? Then we are going over, we are running a for loop, a comma b, and it's returning a minus b, and that's being put into a for loop, into a list. And that's about it. And there we go. All right, can you make it smaller? I think so. You can just say return and delete this. There we go. Okay, personally, I do not like this for loop. Okay, it kind of get lost in the code and you feel that, oh, there is no loop. And because usually a loop has a indentation. So when you are reading the code blocks quickly in a larger one, this kind of loop get missed out. Okay. And though it's very handy, very, very handy. Okay. All right.
This is like a lambda function, right?
No, I'll come back.
I will look like a one-liner of lambda function.
Yeah, it looks like one-liner of lambda.
Yeah. Is that from ChatGPT or someone passed it to you? I don't know. Like,
what?
I was a bit late to start. Is that from ChatGPT or someone else has written?
No, this is Shweta's code.
Oh.
Yeah, Shweta's
Sorry,
code.
no offense for anyone.
Sandeep, for zip, we can have more than 2 lists, right? We can n number of lists, right?
For zip, I think so. Zip, let's just see. 1,
Yeah, Sandeep, we can do.
Okay, I think so.
Yeah, I just tried, yes.
Though in real life, the zip only takes 2 sides of the chain and puts them together. Okay. But you can infinitely do it, right? Even if it took like 2, you can just take that and combine it with third one. Okay.
Hmm.
Yeah, perfect. Very good. All right. All right. Any other variant? So we talked about, which all variants did we talk about? We said while, for with enumerate, and we did for with zip, then we did list comprehension for loop. Okay. And we did NumPy diff. Okay. Any other thing that you have in mind? Do you think you can do it with recursion? You're subtracting a list of values with another. Okay.
I mean, we can do it with recursion, but will it make any sense to actually do recursion for
Good
this?
question. Very good point. And it doesn't make sense, but just for the heck of it. Yes, it doesn't make sense because it's going to be very inefficient, because we'll be doing a lot of array slicing, array creation. It will be inefficient, but for the heck of it. Just for the sake of it, let's do it. Okay, let's see. Diff factors. I need to think. So, okay. 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 Anyone? Any ideas? So if length of A is equals to 0, and okay, what I'm going to do is I'm going to return an empty array. Okay. Otherwise, if they are both empty, otherwise, what I'll do is I will say result equals diff underscore vector, and I will pass everything after first element. Okay. And what else can I do? Okay. All right. I'll say result equal to A0 minus B0. And I'll say, okay. Okay. I'll call it diff. Okay. I'm creating a single this. And I'm saying result dot extend result1. Okay. Does it work? Oh, it did work actually. Am I using the correct one? I never had a recursion function which can run in the single shot. Okay, I'm suspicious. Okay, it's working, right? All right. Yeah, it's working. Okay. Okay. Why is there so much silence?
So in the first, if we can also add a check to see if both the lengths are equal, right?
Got it. I'm just going with that thing that you're not going
Yeah,
to.
okay.
I agree that there's, yes, so you're right. So basically I have not done the error checking. So you can subtract 2 marks from it.
No, I'm saying that we can do it in this first if loop
Yeah,
only,
yeah,
right? If
yeah.
both are not equal or
Equal,
this return 0.
Yeah, Throw error, yeah. Or you can also say that or length of B equals 0. So in this case also it should work, I think. Okay. What I did, if length of array A or B equals 0, return empty. Otherwise, return.
No, I think it should be length of. It should be not length of B is equal to 0. It is or length of B not equal to length of A.
Okay, length of.
That is the error check, right? Here it length of not equal to, not equal to, not equal to.
Not equals. Okay, okay. In that case, what happened was it gave the error like this. I'm just thinking that let it ignore in the case of, let's say, here I'm saying this is empty, okay, and this is 1. In this case, it should give this, okay. Now let's say this is 1 and this is 2, okay, and let's say 1, okay. If A's length is 0 or this, okay, never mind. So we'll think about the error handling later. But yeah, I hope you all got it. Let's just assume for now
So
that
extent will append another list, and append
correct.
will append new values. Right?
Yes. Let's say you have A equals to this. If you say A append 10, what it does is it puts 10 at the end of the list. Okay. Now, if you say A dot append 3, 4, 5, what it does is, now here is the crazy part. Okay. And what it does is okay. So what it did was first when you said 10, it appended 10 to the list. If you say append another list, it will put that list inside this list. Okay. So basically when we are appending, it is essentially doing that. So in case you want that, instead of appending these elements, if you want that to be extended, what you do is, let me just go over this. Okay. And if you say here, if you say a dot extend, and I'm saying 10, 20, 30. So, right now you can see this list, instead of getting it added like an element, this got added like separate elements. Okay. Is everybody okay with the difference between append and extend?
Yes, Sandeep, append means we can write anything in the particularly single short memory, single step memory.
Yes.
Then we first extract the list, another list, then append to the above list, right?
Yes.
In the internal work in the both functions,
Yes.
right?
What happens if I append the list to itself? If I say A append A, okay. Oh, it went crazy. Okay. Let's just do this experiment. Let's say this is 1, and I'm saying A. Oh, what's happening? 0. Okay. Really? I've never done this before. A0, A1. Ah, it's a recursion. Okay.
Not recursion, Sandeep. This is, I think,
No,
the memory.
it's a recursion if you see. Okay. It's a recursion, dude. Yeah. So A is pointing, it's like a pointer to itself. Okay. So A is containing 1. A is containing 1, comma A. This is A. Now, if I and so if I say 1, so I can keep on checking inside A1, 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 and it'll be like that. Sounds trippy, right?
But
Okay.
here you see my interrupt is like the completed here, not the block, the my kernel interrupt. Then how to recursion is execute here?
No, it's a pointer. It's a pointer to itself.
Okay, okay. Pointer to itself. Okay, okay. Yeah,
Yeah,
yeah.
yeah,
Understand.
yeah.
Yes, yes, yes. Yes, yes.
Okay. Got it?
Yeah, we never find out the value. Yeah, you're
Yeah,
right.
yeah. So if you just change, let's say this value to 0, it would change everywhere. Okay.
Every,
Yeah, you can see the first one also changed. So it's
yes,
like
yes.
it's going in loops. Okay.
Yeah.
Okay. Accidental, but yeah, good. Yes, Sweta?
Yeah, hi, Cindy. Cindy, actually, I have two questions regarding the list comprehension. What is the internally happening in the while parsing it? I see that it is parsing from right to left. Generally, things is happening from left to right. So, is that so that in list comprehension, is it parsing done from right to left? And second question is,
This code, right? This piece of code.
yes, yes.
Mm-hmm. Sort of, yes. It basically would parse from left to right. How, if I have to code the compiler, it would still be from left to right. Yeah.
But here, first it zip the list, then for
Yeah,
loop.
it would basically parse it from like this, but processing will happen like this. First it'll process it, then do that. But if you see from the grammar perspective, from the compiler side, it will be parsing from left to right. Like in regular expression, right? The one that we were writing above, that's a left recursive parser. Okay. The one that Veena was writing, where I was saying, pick the first letter, go to the next, pick the next letter. So it was basically going from left to right. Okay. So similarly here also, it'll be left to right, but execution will actually be from right to left, as you said.
Okay. So
Yeah.
the second question is related with the recursion. So because most of the time, like I use recursion, so it taking a lot of memory.
Yes.
So what is happening inside recursion? Like how it is storing in? Is it storing in stack or heap, or in Python how it is working? Like
Same
how it
thing,
is
like
storing?
it is basically how should I say? It is storing everything into some sort of an internal stack. Okay. And when we said, remember when we said this, okay, define read text, correct? And what we were doing is take input X, okay? Okay. And what we were doing is if X not equal to dot, read underscore text, and then we were printing X, right? So, and when we execute this, okay, read underscore text, okay, when we execute this, let's say I entered 1 and then entered Sandeep and then entered, let's say 34.23 and entered dot, then you see, it basically, what it did in the beginning, right, for the first time, it read the text from you, X, okay, and then checked this thing, then called itself. The moment it called, what it did was, it created a memory in the system and put X equal to 1 in that memory, okay, and again it started executing second thing, and then again when you entered Sandeep, the X is equal to Sandeep, okay, it kept that memory into the system and then again executed it And this next time it would put a 34.23 into the x equal. It's a separate x variable it has created in the memory. And then the x was dot. Okay. And when x was dot, what it did was it printed x while coming right here. It printed x and then came back here, then printed x again, and then came back here, then printed x and came back here, and so on. So first it printed dot, then it printed 34.23, then it printed Sandeep, and then it printed 1. Got it? So here internally, this thing is in a stack. It keeps on stacking new functions. So park the current function into the stack and execute the new function. Then keep on going. And then once you're done, come back, and then start resuming the function call. Got it? Is that does that answer your question? It's a very good question.
Yes, yes, yes.
All right.
So similarly for the for loop also. So for loop is not taking any memory, or it's just a block. It's just taking the whole block.
For loop is not allocating any stack. For loop is not allocating any stack. Every time for loop is overwriting the same variable. When we are running this for loop here, every time this for loop is overwriting index and VA. These variables remain like the same variable values which are getting changed. In case of a stack, the example we took, the same variables are holding new values. Okay, and they are in a separate kind of a frame, one top of another inside the system.
So sir, basically everything, whatever happening in the Python, so it is similar to C, like whatever internally happening, it's similar to C.
Correct. It just, you can say, it is simplified the C, C++, Java. It has basically taken the ideas from all the programming languages, simplified them. Okay. And few things it added. One is like indentation. You have to have indentation instead of curly brackets. Instead of curly brackets, it has indentation. And also that the declaration of values are such that you don't have to compile the code. You just assign, and it's more like a scripting language. So it is a cleaner version of Perl. There was a language called Perl, very cleaner version of Perl and C combined together. Okay. The list comprehension come from Perl, by the way. Okay. These list comprehension came from there. Okay.
Okay.
And most of the programming languages are like this. They borrow the ideas from every other language. Okay. Okay, perfect. Very good questions. And yes. All right. Rupam, you got the answer. If length of array A is not equal to length of array B, you should just throw an error in this case. Okay. You should just throw error. All right. Now,
Can you share a real time, practical example from the industry where we are going to use those vectors and something like that? Maybe graph search we can use. Other than that, anything?
No, so let's take the case of ChatGPT as of today. Okay. Or let's take a case of, right, real use cases, right? Vector, real use cases. Okay. Number one. Okay. It's a very good question. So I think I want everybody to pay attention. When we feed the data to a model, right, the input data is converted to a bunch of numbers. Okay. And that is a factor. Okay. Number two, when you are training a model, when training a model, okay, what you have is the model is an array of numbers. Okay, when we say large language model, this, that, AI models, those are nothing but arrays and arrays and arrays of numbers. Okay, that's again a vector. Number 3, when you are processing an image, okay, what is an image? Image is a two-dimensional or okay. Image is what? Anybody? It has a, it is an array, right? It is like array. It has rows and columns, correct? So the image would look like this. Okay, I will just show you how an image. Okay, I'm just making an image. Okay, image equals np.array. Okay. All right. And did I make a mistake anywhere? Yes.
The spelling of array.
Array, yeah. Okay. From pyplot, from Matplotlib, import plot as py, plt, and I'm saying plt.show. Okay. It says the truth value of what is the method? Okay, so you can see this, right? So it's a image, okay? It's an image where I have put in these values here. Okay, so this is 1, 2, 3, 2, 3, 4. Okay, an image is nothing but a array of numbers. This is a 2 by 3 image. Okay, so an image is an array of numbers, a vector. Okay, a vector of vectors, right? We call this tensor. Now, for audio, what is an audio? Audio is a sequence of numbers. Sequence of numbers. It is a vector. All right. Now, when we are doing natural language processing, right, we convert text into embedding. Somebody is on unmute. He might be invading your privacy. Okay. Yes. NLP, in natural language processing, one of the things that the AI models provide is something called embedding. Embedding is nothing but a bunch of numbers, again, a vector. Number 6, when we are processing the computer vision, in computer vision, we convert face of a person into face embedding called a vector. Okay, so a bunch of numbers called vector is something so critical in the entire computer science that there is a library dedicated to it. Similarly, when you are processing, say, movies is nothing but a vector of images. Image is nothing but vector of vectors of pixels, and so on. Okay, and so there are so many use cases of a vector that which are beyond counting. All right, and does that answer your question?
Yeah.
Okay, so the reason I want you guys to think of it is this, that that, right? The way you just now wrote a simple method of, subtracting a list of numbers from another list of numbers is very, very common. And what we usually do is we calculate, like if you are building a recommendation engine, right? Recommendation engine, right? The recommendation engine that you see on Amazon, for example, what we usually do is we take every product on the website, convert it into a bunch of numbers, right? This product is in this category, this product has got this price, this product has got these many reviews. We convert it into bunch of numbers, right? And then we compare two products by subtracting these two vectors and see how similar are these products. So we come up with those matrices of to do the calculation, like this vector and this vector, how much similar are they? Okay. So representation of a product. Now, that's one of the reasons why there is a new thing called a vector data store or vector database. Okay, which helps you storing bunch of numbers in an efficient way, storing and retrieval. Okay, so I can, like, the entire story about the machine learning and AI is going to revolve around vectors. Okay, and yes, that's something that you would, appreciate at the end of it. Also, I'll want to just give one more digression and come back. It's important for everybody. So when people were designing the translation system, right? Let's say English to Russian. Okay. So people were building these translations. So one of the thoughts was that instead of creating all possible translations, Russian to English, English to Russian, English to Hindi, Hindi to English, Russian to Hindi, Hindi to Russian, instead of designing all permutations, what people did was they realized, let's create something called an intermediate representation. Okay, we will create one translator for this representation and from this. Okay, let's call it intermediate language. So there was in 1970s or 1980s, there was this race to figure out what this intermediate language is going to be. Some people said, let's go with languages like Sanskrit. Some people said, let's go with language like programming language like Lisp. Okay, so there were lots and lots of discussions when we were trying to create, let's say, a language 1 to language 2 translator. Let's just design the translator from English to IL, IL to Russian, Hindi to IL, IL to Russian. Because if we have this intermediate language, then we only have to create how many translations? Let's say there are total 100 languages. If we have to create translation from each one to another, how many would they be? 100 times 99. Okay. And if you have the intermediate language, how many translations will be there? 100 plus 100. So total translator we'll have to create is 200 as compared to 99. So there was a need of creating an intermediate language. Got it? Is everybody with me so far?
Yes.
And after lots and lots of tries, in 2017, it was figured out, what is this intermediate language going to be? Can you guess? Take a wild guess.
Vectors.
Vector.
Binary.
Vector. Yeah, a vector. Okay. All right. So essentially, it is the map. People realize that the way we can represent the meaning of anything, it is a vector. Okay? And all right. Perfect. Okay. Wonderful. Wonderful. So that's a speech on vector. Okay. All right. Though I was planning saving this speech for later point of time, but yeah. Okay. Now, moving on, here, this is a very important question that Hemant asked, and I think this is useful for everybody. And whatever we are doing right now, it is just to give you, this is exactly why I'm pushing everyone to code it, is so that you get familiarized with these ideas while learning to code. Okay, so I think it is right. Instead of like the way we learned English language in childhood was to do these fake translations, right? Similarly, most of the people spend their time learning Python just with those standard examples. The difference in this class is that I want to take more and more real practical exercises while learning Python so that I can solve two things at a time. Okay. Now, this was recursion. Anybody else has a idea here? What else can we do? Yes? All right. So there is another thing called a map and a lambda function. Okay. So what does a map do? Okay. Okay. Let's say you have defined a function called diff. It takes two values, a and b, and returns a minus b. Okay. And what map does is it takes these kind of method and would apply on all of these elements. Okay. All right. So let me show you what does it do. Okay. Don't tell me. Okay. How do I don't it convert it into, it says diff missing one argument. Okay, I got it. So there is a method called map. What it does is it takes a function as an argument. So function can be passed as an argument. That's a very important part. Function can be passed as an argument, and then you can use it like a normal function. Okay. So here we are passing what a function called diff that we have just now coded. We coded diff function like this, passed it a tuple, and we broke the tuple into two parts, a comma b, and then we subtracted them. Now here you have the list, and that's it. Okay, so now I can combine this and define my diff of vectors. Okay, and I'm saying this is my vector A, this is vector B. What it does is, first of all, it does a zip map. Okay, and also you can define the function within function also. Okay, so two ideas. You can define the function within a function. Okay. Okay. And yes. All right. Let's see. Does it work? Okay. Let's see what is happening. It says tuple is not defined. Tuple is not defined. Okay. Tuple is not defined. Yes. Okay. All right. So does it make sense? Too many ideas?
Sandeep, could you just repeat to me what exactly does map do in this function?
Yeah. Map is basically a dumbed down version of for loop. Okay. It takes this function and loops over all the elements of this list. Okay. Right. Like here, I'll just take one more simple example. Let's say define square. Okay. There is a function called square. What it does is it squares all the values, right? So I'm calling square on the list of these numbers, and let me just convert the result of, okay? I'll call, okay? Yeah. So what's happening is that it took this function and run it over all these methods, okay? So you can think of it this way. We had 1, 2, 3. It basically ran square 1, square 2, square 3, okay? And whatever came out of these, it put it into another function, 1, 4, 9. Does it make sense? So rather than
So
bring,
sorry, Sandeep. So can we print it in any other form of data type? Like here we are printing in list. Can we do it another form?
map can only be applied on anything that can be iterated over. Yeah, okay. Map cannot be applied on something that cannot be iterated. So map is sort of a iteration where in case of a for loop, what we do, we bring data to you, correct? Like you have a big list of numbers, 1,000 numbers. We take each value from it and run it. Now, and bring all the data to the local, right? What map does is it takes the code from you. Square is your piece of code, and you hand it over to map and say, hey, can you run this code on this data? And it'll run it. So you are handing over the piece of code to map, and you're giving the list pointer and then letting it run. Okay. Now, any of the big data systems, right? Large big data systems, we use map because code is smaller than the data. It is easier to take code nearer the data. So map function basically is implemented by multiple systems like Spark, Hadoop, and all. What they do is they take the code from you, run it near the data, and give you the result. Like, for example, when you give the SQL query to the system, SQL query goes to the database, runs it there, and gives you the results, right? So similar to that, the map function takes the code from you, runs it, and gives you the result. Okay? So here, we are handing over the code. And that's a beautiful part about Python, that an argument to the function can be a function. Okay, you can give the function as argument. Okay.
Okay.
Perfect. Awesome.
So Sandeep, one quick question. So when you're doing a map, right, the function which we are mapping should the input to that function should be, I mean, same as what we are mapping that function to, right? So, for example, if you create define a function which takes a tuple, then you can map that only to a list of tuple or whatever tuples, right? That is
Yeah.
there, right?
Because this x, what will this x be? This x will be 1. Okay. And this x will be 2, then x will be 3. So if let's say this one doesn't know how to handle a tuple, let's say we are saying x comma y, okay, and it's returning x square plus y square, then it'll throw error saying 1 is not x and y. Got it? So it has to be, you have to understand that this function will have to take input whatever is the single value in this way. Now, if you take a look at here, okay, here our diff function is taking tuple as the input, okay, and we are basically converting tuple into 2 values and subtracting it. So what happens is map will take your diff function, execute the internally what it is going to do, first, okay, first it will take diff, say diff, and pass 2 comma 3 to it, correct? Okay, and then that will be first step. Then what it'll do is it will call this diff function on 5 comma 6, right? And then it'll call diff function on 10 comma 45, right? And the result is going to be this. Okay, the result is going to be this. Okay, so it took the first argument to the map has to be your function. Second argument has to be something that can be iterated over, like a list. Okay.
So if we suppose if you have mentioned like res is equals to map square like that, and if instead of print list res, you can just if we remove list and if just simply just print res, then what it will print?
Yeah, so see, that's the thing. So if you here, let me just show you what res is. Okay, res is a map object. Okay, it's not a list. It's not something that you can print. Okay, that's why I've converted that into a list object. Okay. Yeah. So it's a you can say it's an iterable, something you can iterate over. The result is an iterable, but not a list. Okay. Because list is everything in the memory. This map object may or may not be in the memory.
Okay.
All right. Perfect. Very good questions. So the last way of doing it is using the map function.
Can you create a function like map, zip, or enumerate so we can understand how iterators are working behind?
Okay. No, I mean, see, zip is essentially working like that. Okay. So you can, like, if I have to define my map function, okay, I'll just show you. Okay. Let's say map function. First argument is f. Okay. Second argument is say list. Okay. I'm saying result equals to result for element E in the list. Okay. Result dot append, or let me call it R equals function of E. And then I'm appending that to result. And I'm saying return result. Okay. So this is, I overwrote the the traditional one. Okay, you should not do that. Okay, so now let me just say I've restarted my kernel so that is gone. Okay, so my map takes a function, let's say define a square. It takes x or cube, let's say cube. Okay, and I'm returning x into x into x, and I'm saying my map, call the cube, and this is my, okay. So what happened here? Okay, yes. So let's go through this code. what is it happening is I first of all defined a result called empty. This is empty array. Then I'm going over this list. I'm saying for element E in the list L, result is equal to f of E, meaning call this function f on this element E and put it into R. And then I'm appending that into result. So what is it that I'm doing? Go over all the elements of list L, and for each element in list L, pass it to the function f, and whatever comes out, collect it in the result. Okay. Cool. So we discussed a couple of ideas. We can pass function as argument. We can call function within a function. We can define function within a function. Okay. That function inside the function cannot be accessed from outside. Okay. Now, there is another idea. That another idea is that you can define functions in an inline way, right? Let's say you are trying to define a function called negative. Okay. What it does is lambda x minus x. So I'm just defining a function called negative like this way. Okay. And whatever I pass, it will basically turn it into minus x. Okay. This is another way of defining a function. Instead of saying like this is an alternative to negative x return minus x, I am just using this. Okay. So this is a quicker way of defining an inline function. So I can essentially use my map function here. Okay. Instead of defining the cube somewhere else, I can say lambda x into x into x. Okay. So you can see that I have just defined a function while calling. Okay. So that's another way of handling it, right? So the many ideas we discussed, and yes, don't panic at all. It is completely okay. And now define a function called vector diff. Okay. And these are two vectors. And what I'm doing is I'm saying map, okay, lambda x comma y, and okay, all right, lambda x, x0 minus x1, okay, and I'm saying here, I'm saying zip a comma b, all right, and I'm returning this. I'm just converting as a list, and it should also work. Okay. Many ideas? Too many ideas, is it? So lambda, map, zip, yeah. Okay. It just, pretty simple ideas. Zip brought together every element from both the lists. This lambda function is nothing but a function which basically subtracts the two values. It is basically a minus b. And map function is calling a minus b on all the zipped values together and returning them as a list. Are you guys with me?
Sandeep, it's an inline kind of function, so definitely it is going to consume memory in the system, right?
Yeah, of course. So every time you're going to call this function will be defined and executed. Okay. So lambda functions are, lazy programmers handy thing, but I don't like them because soon enough you need more logic. The moment you need a little bit more work, you will have to define them separately. So the lambda functions, are nothing but inline functions. Okay. Right. Single statement. Okay. And so you can't have multiple statements in those. Okay. The other downside of Lambda functions is, all right, they're short and quick, but they're like use and throw. If you are doing it in a for loop, what will happen is every time you're doing it, it just keeps on redefining. Okay. More memory for defining the function. Okay. Every time it keeps defining the function over and over. If you just have it separate, you don't need to define it again. Okay. All right. So Lambda functions. Yeah.
Can lambda function be multi-line or?
No, it can't be. That's the thing. So everywhere I have started using Lambda, I end up defining the function separately. Okay. A question is, which one is more efficient way to implement all of these approaches? Is there any way we can see what libraries like NumPy use internally, like when we do debugging in other languages? Good question, Vivek. And yeah, very good question. So, all right. Which one is more efficient? That is first question. And second is, which one consumes, right? Yeah. So when we say efficient, we basically try to count how much memory it takes and how much computation it takes. Okay. Now, usually computation and memory is difficult to count. Okay. So what we do is we kind of approximate the order, meaning how will this memory grow with data? Okay. Similarly, with computation, we also approximate the order. Okay. But since all the things that we've studied so far, the memory in case of the recursion was proportion to the number of elements. Okay. Right? Every time you have an element, it's trying to create all of that. Okay. While in other cases, the memory was almost similar. Okay. So computation and memory was almost similar, but right, what libraries like NumPy do? That's the second question. Okay. Okay. These are very important questions for everyone. Okay. So what libraries like NumPy do? Since Python has, Python's list is very flexible. It can have all kinds of elements in a list, right? You don't need to create a separate data type for each list. Therefore, what Python's NumPy do is it uses the language C underneath, right? It uses C's array because that's most efficient, and that's what makes it most efficient. Okay. The easiest way to estimate right now is just run it with time. Okay. Run it with time. How do you do with the time? There is a way to do it with the time. Okay. Where is the time? I remember that. Time it, yeah. So I forgot how do you call something using. So there are the functions like time it libraries. You can use time it, okay, to time the execution. Okay. So usually what people do is in order to compare which of these vector diff is working best, they would create like these lists with say 1,000,000 elements and with million random elements, and then call your library and do the time it. Time it will tell us how much each of the approach is taking. Okay, perfect. So good. We did lots of things today, and I hope this was useful. Okay.
Sandeep, while like in other programming languages, when we debug, we get to see what's the code behind. In Python, there is no way we can see like what internal implementation of that library or something is. Can we see that?
Yeah. See, Python's all these libraries are open source, so you can just go to the internet and check the code.
Okay.
Okay. Yeah, you can check the online code. All right. Yeah, let's take a look at other questions. What were the other questions? Yes. Has anybody implemented this one? Given two vectors. Okay, I think, yeah. All right. Veena and everyone. Veena, Shweta, Hemant. Yeah. Can you share the code?
I have pasted the code.
Okay. Thank you, Madhumita. Okay. Okay. Second question. Okay. I'll just put it in today's exercise. Okay. Let's take a look at the second question. All right. All right. So here is, okay. Yeah. Okay. Okay. This is diff, not the square. Okay. Diff, we have already covered this part. Okay. All right. I'm taking this piece of code. This one. All right. Now, sorry. Let me take this one. Here, we are doing absolute distance. Oh, this is square distance you have done. Okay. This is a square distance. Right. Let me correct, fix it. Now this is who? Okay. Improvement. Okay, absolute. This is from Sweta. Okay. And then this is square distance. This is square distance. Okay. Okay. Yeah. All right. So here we go. So yes. Okay. This one. So this one. So what we are doing is we want to find the absolute distance. What is absolute distance? It's nothing but whatever we did previously. We take those vectors. So after subtracting, you convert all of them into positive values and then sum them up together, right? That's all. So 1 minus 2 is, right? 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1. So the total is 1 plus 1 plus 1. Here, 5 minus 2 is, okay. Let me turn on charging. Okay, so here 5 minus 2 is 3, 4 minus 3 is 1, and 4 minus 3 is 3. So 3 plus 3 plus 1 is 7. Okay, so yes, let's take a look absolute distance between L1 and L2. So again, first what she did was she did the subtraction using the previous one. Okay, and then you can just call that same function to find the diff. Yes, and then what she did was she went over all the values and added to the distance. Okay, added to the distance. Now this will be trouble because first value will cancel out the second value and the ABS needs to be here. Okay, not here. That's all. And there we go. Perfect. All right. Is this code clear to all? All right. So we can simply say here, right? Can simply say, all right, let me see. We have to find the absolute distance. Okay. And there are two vectors, A comma B. Okay. And what I'm going to do is I'm going to say index equals 0 while index is less than length of A. Okay. And total equals 0, or I'll just call it distance equals 0. I'm saying distance plus equals A of index. Okay, I'll just do this. Okay, I'm saying difference D equals A of index minus B of index. Okay, if diff is less than 0, I'm saying diff equals minus diff. Okay, and then I'm saying distance plus equals difference, and I'm returning the distance. Okay, is this code clear? Yes, I again forgot to increase the index. All right. Cool. Okay. Is everybody okay on this? I would want everybody to code up by themselves. Okay. All right. Now, great. Now, similarly, given two vectors representing points, we can find the square distance. Okay. How do we find the square distance? 1 minus 3 square and so on. Correct? This is okay. And distance 3D, you can do the same thing. All right. Are you guys okay with this? Do you want me to solve any of these questions or you're okay? Perfect. Thank you, Abhijit. Okay, so your solution is right. So let me copy everybody's answers in a single shot. Okay. Oh, it's not allowing me to copy everything. Okay. These are the answers from everybody. Okay. Right. Okay. So this is an absolute distance. So this we corrected. There's a minor correction. Then this is a distance of 3D points. So 0.1, 0.2. So zeroth coordinate of point 1 subtracted with the zeroth coordinate of point 2. So x, y, z, computed x and y and g, and then squared each of them, x square plus y square plus z square. And then after summing up all the three things, he did the square root. Perfect. Perfect. Okay. Is everybody okay with this? Please feel free to stop me. Okay. Now this is a distance again between n dimension. If you have n dimensions, 0.1 and 0.2, so what you do is you go over this. Basically, he's using something called range. Range is nothing but it basically generates those many numbers, right? Let's say range of 10 generates the range object. You can just take a look at what's there in the range object by translating it into a list. So you can see range 10 produces 0 to 9. Okay. When you say range 2, 10, it produces the values from 2 to 9. Okay. So range is, this is inclusive and this is excluding 10, but including 2. Okay. And you can say, 2. So every time it will start from 2, it will go up to, but not equal to 10, and it'll keep on increasing every time by 2. You can also say this, okay? And you can generate thousands of numbers in this way, okay? If you want to start with, say, table of, table of 3. No, this is not the table of 3. Yeah, this is just a gap, gap of 3 values. Yeah, this is a table of 3, 0, 3, 6, 9, 12, up to going on, right? So this is a range. It generates that list, and then you can use it with the for loop. That's what he has done here. So for I in the range, meaning go up to this length, right? This is a common syntax you will see. If you want to go over all the indices of a array, you will say, find the length of this array and do the range, okay? So like, for example, if you have an array A, it has some elements, let's say 10, 20, 30, and you say, for I in range length A, you can say print I, okay? So you can see it has basically length of A is 3, so range 3 is equal to 0, 1, 2, okay? So that's what is happening. So to iterate over the indices of array, you use this kind of syntax. And then we are saying square distance plus equals to 0.1 ith value minus 0.2 ith value and square of it. And then we keep on summing into it and then do the square root. Similarly, absolute distance, exactly this. The while index is less than array, exactly what I just now did, except for here, okay? So just that you need to know that you can essentially say value equals minus of value, okay? That's easiest one. When I came from the C background, I was also doing the same. This instead, this is way more easier. Okay. Now, Abhijit's point here is that find distance between A and B. So go over, this is the n dimension one. So for I in the range length A, sum AI minus BI, and then square it, and then you basically sum it, and there you go. Perfect. And I hope this is useful. All right. So these are a few questions, and you all have done pretty good job. Okay. Now, I want to leave you today with a simple question. Okay. All right. Is everybody with me so far? Okay. Question 1. Okay. I want to start tomorrow here. Okay. Coin toss. Okay. Create a function that returns 0 or 1 with equal probability. Okay, so you can say that 0 is equivalent of head and 1 is equal to tail, and you are doing a coin toss. Okay, so if basically I will call your function coin underscore toss. Okay, and it should basically give me 0 or 1. Okay, 0 means head for me, when 1 is tail. Okay, and it should give with the equal probability. If you call your function coin toss 1,000,000 times, head and tail should come approximately equal. Not exactly, I don't want exact, just approximately. Okay. And here the hint is, okay, hint is, right, random dot random. Okay, so there is a library called random. You can import random from it. Okay, random is a function, and random is also the file name. Okay, so when you call random, it gives a decimal number between 0 and 1. Okay, so you can use random. Okay, and that is one of the exercises. All right. Is the question clear, everyone?
Yes, Sandeep.
Okay. So the way I'm going to test your function is I will basically, I will say for, okay, coin underscore toss. Okay. And okay. Okay. Coin toss. Okay. For I in 10,000. Okay. And then I'll say sum of result divided by length of result. This should be equal to 0.5. Okay, meaning I will call the coin toss function 10,000 times. Okay, it would return either 0 or 1. Okay, and I will check how many times 1 has been returned. It should be close to 0.5. Okay. Is the question clear to everyone? Please feel free to ask.
Like Sandeep, this coin toss value always true value. If is the return head, else return is the false.
Yes.
So always, if the 10,000 time we call that, the possibility is we take the 5,000 time is the head and 5,000 time is the tails.
Yeah.
Then always is the 1 and 0.05. Can you describe a little bit more?
Meaning? So
It
your
means
coin toss should return either 0 or 1.
yeah.
Okay. 50% of the time it should return 0. 50% it should return 1.
So is there any concept of static variable kind of in C plus
No.
or C we can do like
No,
if it
even
was
if it
true,
is,
then next time we
even if it is there, we are not going to implement it like that. Okay.
okay.
Let me repeat. It doesn't need to return exactly that many times. So your coin, your function doesn't know how many times it has been called. Your function doesn't know what it returned previously. It just return just like a coin, it has to return 0 or 1. Now, here is the very important hint for all. There is a function called random.random. Every time you call it, it gives you a value. It gives you a value which is between 0 and 1. Okay. For example, you can say for I in range 10, I'm just showing you 10 times. Okay. I'm printing random. Okay. So you can see that it is a value between 0 and 1. Okay.
Sandeep, the one use case, if suppose we random function we are using, like assume that the first value is the random is the possibility of the head. Then the
Yes.
remaining value is the possibility of the tails, right?
Yes. No, so basically your function will be your function should just return 0 or 1. It'll be called many times, but your function should return like a number between 0 and 1.
So this random dot random, no, that returns equal probability. Is it already there in that?
Come again? Yeah. It returns a random number. That is guaranteed.
No, it returns with the equal probability also.
Yes.
Is that
All values could be random between 0 and 1. Okay.
Okay. So can I assume that if I'm in this, so if I'll get 0.5 less than 0.5
Okay.
and greater than 0.5.
So you are saying
will be
you
of
will
equal probability.
You are saying, okay. Yeah. Help me out. Yeah. Very good. Yeah. Go ahead.
So if it is, if the random is giving me a value less than 0.5,
Okay.
then I'll map it to head.
Okay.
0, yeah.
And if it is greater than 0.5, greater than or equal to 0.5, then yeah, 1.
Is this code okay?
Yeah.
No, it won't give 50. It doesn't give 50% probability, right?
Whether
Because
this
it
will
should
give,
be.
that is my question
It
actually,
should be
whether random
slightly.
is giving that.
No, it is giving random. I think the issue with this
Let's
code is
test it
that
out. Let's
it is
test
not.
it out. Let's test it out. Okay.
It is not doing it for the 50%.
Let's test it out. Okay. It says the int object is not iterable, so I'll just say range. Okay. Not bad. Not bad. This is almost like 50, right?
It should be less than 0.6, right?
No, we said equal.
No. If your R is less than 0.6.
Okay. Random. Oh, you are saying that random will never give 1, is it?
No, I'm saying that if you want to compare from
Let's say
0 to
we are
1,
saying
right?
0.6, right?
Yep.
Let's see. Is this okay? No.
0.
See, total number of times the head came is 60% of time.
Yeah.
And 1 only came 40% of the time. Okay, you can just take a sum of the result and that tells you how many times 1 came. 1 came 3,943 times out of 10,000 times. Okay, which means this seems to be more logical because 0.56, 0.58, 0.59, all of those values are counted, right? If you say 0.6, right? So the way you can think of it is that okay, if you think of it, right, between 0 and 1, a random number is going to be generated. Okay. Now we are saying 0.5. Okay. If any of these values are generated, call it 0. Otherwise, call it 1. And what you said was, okay, don't go for 0.5. Go for 0.6. Okay. So if all the values are less than or equal to 0.6, then basically 60% gives 0 and 40% times it gives 1. Okay.
I think what Subodh meant was if it is less than 0.6, then it will be inclusive of 0 to 0.5. And from there, it's
No, you
0.6
see,
to
0.5,
that.
0.5000001, like that, right? That is what it meant. So if you can at most say r less than equal to 0.5.
Yeah.
Okay, because it's not integers, it's like decimal numbers. Now you can see this is actually good, not bad. Okay, but here you can see it has suddenly dipped. Okay, so to me, this seems like a good idea. Yeah.
This is random, that's why every time.
Yeah. Okay. Is everybody okay? No?
So that answer is correct? No.
This answer is correct.
Yeah.
Okay. Even equal is okay. Even if you put equal, it's still okay. Yeah, it's still okay. Subodh, are you able to connect?
Yeah, no, yeah, I got it. Yep.
So if the random number is less than 0.5, it is going to give 0, otherwise 1. Is everybody okay with this?
Yes.
Okay. Now, right, I want to make 3 more questions out of this question. Okay. All right. Now, what I want to do is I want to create question number 2. I want everybody to code it by themselves. Okay. Even if like after this class, you guys should code it by yourself. Make a note of the question. Okay. The question number 2, create a function that returns 0, 1, and 2 with equal probability. Okay. Okay. Now, question number 3. Question number 3. Okay. I will. Okay. Question number 3 is. Okay. Question number 3 is. Again, coin toss. Okay. Create a function that takes n. Okay. Create. Okay. Create a function that takes n number of faces. Okay. Okay. So now you have to generalize. So first we did for 2 faces, 0 and 1. Now we said create a function that returns 0, 1, and 2 with equal probability, meaning 3-faced coin. Okay, or 3-faced die. Now we are saying consider that right, you basically define a coin toss which has let's say define coin underscore toss, and I'm passing n as argument, and if okay, and it should just return 0, 1, 2, 3 up to n. Okay, it should not return n, it should return 0 or 1, 2, or 3, like that. Got it? So it should return any of these numbers, and that's it. Okay, so you are doing coin toss, and it's a fair coin toss. Okay, it's a fair coin toss. It should just produce the fair coin toss. Okay, now all of these ideas are extremely important. I want you, everybody, to code it up. Okay, because soon enough this thing is going to escalate. Okay, I'm going to escalate it very soon. Okay, that's why I want everybody to be super comfortable with this particular idea. Okay, try coding by yourself, go back and sit down and try to code it, then code this one, create basically first 2-face coin, then 3-face dice, then n-face dice, right? To which if you say coin toss 6, it will produce 0 to 5. Okay, Now, question number 4, right? Question number 4, unfair coin. Okay, unfair coin. Okay, right? Unfair coin is, right? It takes the probability P1 and P2, okay, and returns 0 P1 times, okay, 0 with P1 probability, okay, and return 1 with P2 probability, okay, and yeah, and to convert it, all right, first of all, divide P1 with P1 plus P2, okay, and then P2 divided by P1 plus P2, just to make sure that both P1 and P2 are the probabilities. Okay. So essentially, if somebody says coin toss, okay, coin toss, we am saying 0.8, 0.2, it means, okay, print 0 or return 0 80% of time, and 1 20% of time. Okay, so I'm creating an unfair coin or a biased coin, which is printing 80% time 0 and 20% time 1. Is the question clear, everyone?
So in this case, Sandeep,
Yeah.
like earlier in the fair coin, we will have the equal probability where 0.5. So
Yes.
instead of it, we can have a 0.8.
Yes.
Okay.
Okay. All right. Okay. Again, I want you to hear here. I want to do it like, right? It should be, let's say, with three arguments. Okay, 3 arguments, meaning, right? Coin toss takes 3 probabilities, P1, P2, P3 as argument. Okay, this is a question number 5. Okay, and sorry, and 3 probabilities P1, P2 as arguments, returns 0, P1, 0 with P1 probability. Okay, 1 with P2 probability, and 2 with P3 probability. Okay, the question is not hard, by the way, everybody. The question is not hard. The question is all about understanding of the problem. What I understood so far when I showed this question to many people, those who could not solve it were those who did not understand the question. Okay. And yeah, so essentially, almost every programming problem, 90% of the hurdle is understanding the problem. Okay. Okay. So go over, like you should always ask for examples. That can you tell me some examples, like what will happen in this, what will happen in that. Okay. And run down multiple scenarios. Okay. So I am now creating a coin which is biased. It takes 2 probabilities, P1 and P2. It returns, let's say, head 80% of the time, tail 20% of the time. Okay. Now I'm creating a 3-face dice in which there are 3 possible outcomes, 0, 1, and 2. So this takes, let's say if I do a coin toss, okay, I call it coin toss underscore 3, coin toss underscore 3. It takes, let's say 0.8, 0.2, and 0.1. Okay, it would basically give 0 80% of time. Okay, if I call this, let's say 100 times, approximately 80 times, it will give 0. It should give 0. And 1, 20% of the time. And 2, 10% of the time. Okay. All right.
It should be
But
100,
Sandeep,
right?
Yes.
oh sorry, same question.
0.8,
Yeah.
0.8, 0.2, and 0.1. It will be more than 1, right?
Yeah, thank you.
110.
Thank you. I'll just correct it. Okay. Yeah, that's one of the biggest thing. That's why I said first fix the probability so that if somebody makes a mistake, it should be, corrected. Okay. Is everybody okay now? So 70% time 0, 20% time 1, and 10% time 2. Got it? If I call it 1,000 times, it should give, say, 700 times, it will give 0. 200 times, it will give 1. And 100 times, it will give 2. Approximately. Not exactly, approximately. Okay? Is the question clear to everyone?
Sandeep, I just had one question. Can you use all the methods or the functions within the random class, or should we just use random.random to figure out these?
You have to use only random.random. Yeah.
You have to.
Yeah. You have only one tool called random, which gives you the decimal number between 0 to 1. Okay. Now, yes, that's a good question. Use only random.random from random module. Okay. Yeah, because there'll be some module somewhere who will do the same thing. Okay. I hope everybody is on the same page.
Sandeep, in case of the n times, so there we have to use a loop method, no?
Yeah. You will have to use loops and everything. Okay. Here, the question number 3, right? This one. Yeah. This is the one that you are asking about, right?
Yes, Sandeep. Yes.
Okay. Yes. Perfect. Perfect. I am sharing this notebook right away. And yeah, spend some time. I am really happy and very excited about, the way the class is going, because these are useful, and trust me, the ideas like large language model, right? How does it produce word and next word, and there's something called temperature in it. All of those ideas are based on such simple things. Okay, and I'll show you that part. Okay. And yeah, basically these things, even though they are pretty simple, but they're pretty useful, and they soon become complex. Okay. And this one that I'm saying, the unbiased coin, this is also, sorry, the biased coin, the one that we are saying, this is also one of the interesting aspects in case of the AI. Okay. So imagine that you go to a restaurant, okay, and 80% time you want to eat, let's say dosa, and 20% time you want to eat idli, right? In case you don't do a coin toss and you just say, okay, 80% time is what takes over, and I will eat only dosa. Okay. Now, you will never experience idli in your life because that always came as a lower probability. Okay. So, to improve our own exploration, what we usually do is we take chances, we do the serendipity, we take chances. And instead of taking equal chances to idli and dosha, we say that, okay, we'll do a biased coin toss that, okay, we have like out of 10 times, we will go and we will have 8 times, we will have like a dosa, and 2 times we will do the idli. Okay, so that's why the unfair coin toss is used for generating the serendipity. Okay, this is essentially for generating the serendipity. Okay, the unfair coin toss is a very, very useful and powerful question. And when we do it for n number of variables, right, I would want it to generalize in question number 6. Okay, generalize question 5 to n number of faces. Okay, takes an array of probabilities and return the return between 0 to length of array. Okay, with those probabilities. Okay, so those are the few questions that I have for you. All right, so these are 6 questions. Okay, I am asking you to design a fair coin and then an unfair coin. And these are very, very powerful ideas. And I will also talk about something called a temperature when it comes to the OpenAI or any large language model, which is essentially designed on this. Okay. And we'll talk about how do you, decimal wise increase the serendipity and decrease the serendipity, and how would you code that part? That, okay, I want it to be 90% serendipitous. I want it to be lesser serendipitous. Okay. I like that. How would you code that part? So we'll talk about that tomorrow. And yeah, I would expect everybody to code it up. Okay. So
Sandeep,
yeah.
What do you mean by serendipity? It is the same as the probability you meant?
Serendipity is like, what is serendipity? Serendipity is you take chances, correct? Right? So here the coin toss is essentially is making a choice. Okay, it's basically, instead of giving you only head, it's giving you head with 80% chances. Okay, so we use this kind of a coin toss when we are taking chances. So when a model is producing an outcome with 80% head and 20% tail, instead of just picking the head always, because head is the most probability one, highest probability one, we say, okay, we'll pick the head with 80% probability. Okay. Similarly, we will eat dosa, right? As I said, let's say our brain is saying 80% I like dosa, 20% I like idli, right? And so we'll say that, okay, we did a coin toss and it gave 80% dosa. I mean, not coin toss. Our brains told us that, okay, I like dosa 80%, idli 20%. Now we are saying we'll do a coin toss to pick the idli versus dosa, right? Instead of doing the complete random, we are saying, give me dosa or idli such that dosa is 80% of the time and idli is 20%. So coin toss will give me dosa or idli and I'll have to eat it. Okay. So I'm basically having a biased coin. It's not an absolute serendipity. It's a proportional serendipity. Okay. So I have a biased coin in my pocket rather than basically doing random stuff. I am throwing this coin with those different probabilities. Okay. Did I answer your question?
Yes, Sandeep.
Perfect. All right. Yes. Thank you, Hemant. Yes. So in AI, when we will be building the models and training the models as we go in this course, we will have to uh, make sure that our model doesn't become such that he only eats dosa. He should also, that the model, not he, it should also try idli. Okay. So we will make sure that it is exploring and exploiting at the same time. Okay. And most of the AI models, whether it's ChatGPT or Gemini, everybody allows you to fine-tune this serendipitous behavior by setting something called a temperature. Okay. So yeah. So this coin toss is important. And even, right, it's a pretty simple thing. It's just to make sure that all of us can feel it. Okay. I want you to code it up. All right. All right. I hope it was useful. Thank you so much. And yeah, there'll be too many ideas, but these ideas are pretty simple and these are common sense to us. We do it day in, day out in our normal life. Yeah. Yes, Sweta, go ahead.
Yeah, actually, I have one question related with the blue school. We have given one question.
Blue score, yeah.
Yes, so actually, I'm sharing the code.
Okay. Okay. Please go ahead with sharing the screen.
Oh, no, I'm sharing code. Just
Okay.
let sir, actually, my question is like I'm struggling with the log zero problem. So because
Log
it is
zero.
undefined.
Okay.
Yes, it is undefined. So how
Yeah.
we can tackle this in this code?
Yeah.
Maybe
Usually,
I'm
usually what happens is divide by zero kind of problems, right? If you have one divide by zero kind of problem. So usually we change the formula such that we add something like, e to the power minus 0.8. Okay. So let's say wherever we have to do, let's say 1 by x. Okay. And x is 0. So this will be division by 0, correct? So what you'll do is change the formula to include a tiny bit of value in the denominator. Okay. Okay. Not this. Yeah. Okay.
okay.
Yeah. Something like this. Okay. So you suddenly see that this is a tiny bit value. So this has
Sir,
given
are
us.
you sharing your screen? Because I'm
Sharing.
not able to.
Oh, sorry. Yeah. You can see this. Yeah, you can see the screen.
Yes, yes.
Okay. All right. So that's a kind of thing that you will do often. And we will do this. It's good that you discovered it. And very, very, very good thing. All right. So we'll discuss this probably at a later point of time, but this is good. I'm very happy that you were able to code it up. Good. So, and you discovered new things. One is like this. If let's say C is 0, this will be division by 0. And similarly, there will be many more problems that you'll face. Okay. And these are good things. These things is what make you realize that the formulas, most of the formulas are not perfect. And many things that may look like very obvious to people, but when you start coding, you will face these edge cases. Okay. Very good. Very impressive. All right. Okay. Perfect. Perfect. Thank you, Sweta. All right. Okay. So everyone, yeah, keep keep working on this, and this is what will make you do good things. In case you're not able to solve all the problems, it's completely okay. If it's taking too much time, it's completely okay. But solve problems. Okay, solve problems. And the rate of learning is exponential. Okay, one very common misconception is I finished one problem in 1 hour, so 100 problem I'll finish in 100 hours. That's wrong. Okay, that's very wrong. The difference is if you finish the first question in 1 hour, the second question will take 5 minutes, next question will take 1 minute, and so on. And your growth is always exponential. That's a very most important thing to learn. Okay. And I always have seen this very different thing. And because of too many things, you kind of get scared and then you don't do things. Don't get scared of it. Just do it. I mean, just do it. Just work on it. And spend your time. Spend your time. It demands time. Okay. It demands time. Okay. It's okay to get stuck. Okay. It's okay to get stuck. It's okay to get stuck for a day. If you think that you can make progress, it's only, debug, 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 and you are able to move, keep on moving, keep on trying, keep on trying, keep on trying. And then, like, if you are not able to make any progress at all, you are not getting any idea about a problem, then you look at the solution. Okay. And also look at the solution once you have solved the problem. Okay. And yeah, so that way you'll be able to compare as well that, okay, what happened? Like, that's why in this class, I would want all of you to code matrix multiplication, code equation solving, code almost everything, right? So it's a good thing. It's a good thing. And for you, the greatest and the most complex ideas will be way more simpler at later point of time. When you look at all the reinforcement learning, all the large language models, they would look way more simpler. Okay. And all of the things will look connected, but okay, it is essentially this, right? For me, I have seen this very, very clearly in my career. When I was looking at every model as a separate thing, and I was trying to memorize, all of the things look very confusing. And I always had this fear that, oh, this is missed out, that is missed out. How would I handle this? But when I went through simple thinking about how would I code it, then I realized that it's all so simple and obvious. Okay. And like many people suffer from multiple simple questions. Like when I ask them a simple question like temperature, how it works. And the coin toss is my favorite interview question. Okay. You usually just give the probabilities, let them do the unfair coin toss. Okay. And maximum people make mistake in that. Okay. So yeah, I would want everybody to just start coding with me. Okay. This is most important. And trust me, this is the time that would change you. All right. Thank you, everyone. I hope these sessions are helping and I'm not, you should not get a feeling that you're left behind. I have coded for a long time, so I'm able to code things very quickly. And don't feel that, okay, there's something wrong with you. No, there's nothing wrong with you. Everybody is very much capable of coding. Like I get these questions a lot. Okay, specifically my girl students, the women students, right? When their code doesn't work, they come to me and says, there's something wrong with me. And the guy is a student, and the code doesn't work. They say something is wrong with your lab. Okay, and yeah. So I've seen this in many classes. Okay, so but most important part is you don't have to think that way. Okay, you don't have to think that way. You only have to think that how can I solve these problems? How can I solve this? How can I solve this? Only think. Don't think about anything else. Nothing else matters. Okay, nothing else like whether coding is right thing for me, coding is wrong. Don't think about anything. Everybody can code. Everybody is capable of coding. The difference between me and you would be the number of hours I've given to coding. That's the only thing that is different. Okay. And my roommate in college, right? So I took in summers, first year summers, I did not go home. I was in college. I was practicing coding. Okay. I was working in the entire summers. Okay. And when in the second year, everybody got the coding in their curriculum. Okay. My roomie, unfortunately, I got the like doubles room in second year also. So my roomie was, he was struggling with the basic code, and he would come to me and I'll just solve it in a single shot. And he would feel depressed that there is something wrong with him. How can I think so fast? And so on. And then I told him that, dude, you don't have to feel bad. I spent my entire summer and my first year, second semester, just coding. Okay. So there's nothing wrong with you. There's absolutely nothing wrong. It's just that I have given more hours. Okay. And all these edge cases I have seen already, the one that you're struggling with. Okay. So yeah, that's very important part. So the difference between me and somebody who is not good with coding is only the number of hours they have given. Okay. So it's only the amount of time you spend in problem solving. Okay. The more number of problems you solve, the better you get. As simple as that. Okay. All right. So thank you, everyone. Have a good day.
Thank you, sir.
Thanks, Sandeep.